Welcome to all in online lecture series organized by Brahmadev Dada Mane Polytechnic Solapur. Myself, Dr. Praveen Bhalerao. Today, we are going to discuss about the course Basic Science Physics, in which the unit first is Units and Measurement. In this unit, the articles Introduction to Significant Figure, Rounding of Figure, and Convergence. Now, first of all, we will discuss about the significant figure. In shortly, we can say that SF. SF is defined as a figure which is of some significance, but it is does not necessarily denote a certainly. Now, the rules for finding the significant figure. Rule number 1, all the non-zero digits 1 to 9 are always SF. Example 1, 37.71 has 4 SF. Second example, 3.14 has 3 SF. See here in these two examples, there is all non-zero digits and therefore these are all SF. Now rule second, all the zeros between two non-zero digits are SF. Example 1, 2704 has 4 SF. Example 2, 2.9007 has 5 SF. See here, the zeros comes between two non-zero digits and they are all are SF. Now rule number 3, all the zeros before non-zero digits are not SF. For example, the first example is 0.786 has 3 SF. Second example 0.01966 has 4 SF. Now rule number 4, all the zeros behind non-zero digits. In this rule, the sub-rule A is the trailing zeros in a number with a decimal point are SF. Example first, 2.5400 has 5 SF. Second example, 2.970 has 4 SF. Sub-rule B, the trailing zeros in a number without a decimal point are not SF. For example, 123 meter, which is equal to 12300 centimeter. It is also equivalent to 123,000 millimeter has 3 SF. Here the trailing zeros are not significant. Rule number 5, if the number of digits is more than the number of SF, then the number should be expressed in the power of 10, but the power of 10 is not SF. For example, the velocity of light, which is equal to 3 into 10 to the power 8 meter per second, has 1 SF. Here the power of 10 is not SF. The digit 3 is only 3 digit is SF. Now rule number 2, radius of earth 6.4 into 10 to the power 6 meter has 2 SF. Now the rules for finding of approximate numbers. Rule first is if the last figure to be dropped is less than 5, the last figure retained remains unchanged. Example 1, 94.34. In this example, the last figure is 4 and it is less than 5, therefore it will be dropped and the remaining figure 94.3 is considered. Now example 2, 4.6354. Here also the last digit is 4 and it is less than 5, therefore it can be considered as 4.635. Therefore here the last digit 4 is dropped and the figure we can write 4.635. Now the second rule, the last figure to be dropped is greater than 5. The last figure retained is increased by 1. For example, 63.78. Here the last digit is 8 and the preceding digit is 7. Therefore, 8 is the last digit 8 is greater than 5. Therefore, in the preceding digit 1 can be added and we can write this figure as 63.8. Second example, 78.69. This figure we can consider as 78.7. Here also the last digit is 9 and it is greater than 5. Therefore, the preceding digit 6 in which 1 is added and we can write this figure 78.7. Now, rule number 3. If the last figure to be dropped is 5, here the sub-rule A is if the preceding digit is even, the last digit is simply dropped. For example, 2.745. In this example, last digit is 5 and preceding digit is 4 and the 4 is even. Preceding digit is 4 and it is even number and therefore the last digit dropped and the remaining figure we can consider as 2.74. Second example, 28.785. Here also the last digit is 5 and the preceding digit is 8 and 8 is even number. Therefore, the last digit 5 is dropped and the remaining figure we can write 28.78. Now sub-rule B. If the preceding digit is odd, the preceding digit is increased by 1. Example 2.755. The last digit is 5 and preceding digit is 5 and here the 5 is preceding digit and it is odd number and therefore in this odd number 5 1 can added and we can write the figure 2.76. Example second, 49.475. In this figure the preceding digit is 7 and 7 is odd number. 1 can be added in this 7 and we can write 49.48. Now this is the conversion table. Some conversions are given in this table. The first is 1 millimeter, which is equivalent to 10 to the power minus 3 meter. Second is 1 centimeter, which is equal to 10 to the power minus 2 meter. The centi means 10 to the power minus 2 meter. 1 gram, which is equal to 10 to the power minus 3 kilogram. Next is 1 minute, which is equal to 60 second. Next is 1 micro. Micro means 10 to the power minus 6. After that 1 kilo. Kilo means 10 to the power 3. Next is 1 nano. The meaning of nano is 10 to the power minus 9. 1 pico, 10 to the power minus 12. 1 giga, which is equal to 10 to the power 9. 1 mega, which is equal to 10 to the power 6. And next is 1 ton, which is equivalent to 1000 kilogram. Next is 1 angstrom unit. In shortly we can say 1 AU, which is equivalent to 10 to the power minus 8 centimeter, and further it is converted to meter, 10 to the power minus 10 meter. And next is the energy in electron volt, which is converted into joule. 1 electron volt, which is equal to 1.6 into 10 to the power minus 19 joule. Next is 1 quintal, which is equal to 100 kilogram. And last is 1 pound, which is equal to 0.4536 kilogram. So in this way, today we have studied about the significant figure, the rules for finding of significant figures and their examples. Also we have studied about the rules for rounding off of approximate numbers and their examples, and lastly the conversions in the conversion tables. Okay, thank you.